Welcome to my presentation. Today I am presenting the topic about frequency translations and mixing. In first, we have their content. First, introductions. What is frequency and translations? The basics of frequency mixings. The importance of frequency translations and mixing. Frequency translations technique, frequency mixing techniques, frequency translation and mixing in 5G communications, applications of frequency translation and mixing, advantages of frequency translations and mixing, and the last one is conclusions. So here my first slides about introductions. Today we will be discuss frequency in translations and mixing. The importance of these will be explored in areas such as telecom, signal processing, and radio astronomy. Have you ever considered the transmissions and receptions of signals or how information is extracted from them? Frequency translations and mixings are important in addressing this question. By changing a signal's frequency, we can enhance its quality, lower interference, and extra informations. Let's explore this topic further. In my next slides, what is frequency translations? So, frequency translations is the process of shifting a signal frequency from one band to another. This technique is commonly used in communication system to allow different devices to communicate with each other, even if they operate at different frequencies. In frequency translation, the original signal is mixed with a local oscillator signal to produce a new signal with a different frequency. This new signal can then amplified and transmitted over a new channel. Frequency translation is an important tool for modern communication system as it allows devices to communicate over longer distance and different environments. In my next slide, the importance of frequency translations and mixing. The ability to translate frequency and mixing signal is essential in current communication system. These concepts are necessary for effective transmissions and receptions, enabling long-range communications between devices. Without them, many of the technologies we are really on today would not exist. Frequency translations and mixing play important roles in various fields, such as satellite communication, television broadcasting, and medical imaging. This method allows signal to travel through different frequency bands, transmit over airways, and create detailed body image for medical diagnosis. In my next slide, frequency translations technique. Frequency translation technique are method used in various fields of engineering and signal processing to shift the frequency spectrum of a signal up or down by a desired amount. This technique are commonly employed in communication system, radar systems, defined radios, and other applications where frequency manipulations is necessary. Here are some commonly used frequency translation techniques. Heterodyne, mixing a signal with a local oscillator to shift frequency. Unconversion and downconversions, shifting a signal frequency to higher or lower values respectively. Frequency multiplier and divider, increase or decrease a signal frequency by a specific factor. Digital frequency synthesis, generating precise frequency using digital techniques and phase lock loops. In my next slide, frequency mixing technique. Frequency mixing technique, also known as frequency conversions technique. They are methods used to combine two or more input signals with different frequencies to produce output signal with new frequencies. These techniques are widely used in various applications including communication system, radar system, wireless technology, and signal processing. Here are some common frequency mixing techniques. Heterodyne, mixing two signals to create new frequencies using a mixture. Harmonic mixing, using nonlinear device to generate new frequencies based on harmonics. DSB-SC mixing, modulating signal to suppress the carrier and produce new frequencies. SSB mixing, modulating signal to retain only one sideband and reject the other. Image direct mixing, rejecting unwanted sidebands during mixing to avoid interference. In my next slides, frequency translations and mixing in 5G communications. Frequency translations and mixing play crucial roles in 5G communication system, enabling efficient signal transmissions, receptions, and processing. Here are how they are utilized in 5G communications. Frequency translations in 5G communication, carrier aggregations. One of the key features of 5G is carrier aggregations, where multiple frequencies band are combined to increase the overall data throughput. Frequency translation is used to bring the signal from different band to a common intermediate frequency or baseband where they can be combined and processed together. Local oscillator. Frequency translations is essential in generating local oscillator signal used in mixer and up converter. These local oscillators help in converting signal to the desired frequency for transmissions. Next, frequency mixing in 5G communications. Down conversions in receiver. In 5G receiver, frequency mixing is employed to down convert received RF signal to lower intermediate frequency or baseband signal. This down conversion reduces the signal frequencies to a more manageable range for further processing and demodulations. Up conversions in transmitter. Mixing is used to up convert baseband signal to higher frequencies suitable for transmissions over the air. The up converted signal are then amplified and transmitted through the antennas. In my next slide, applications of frequency translations and mixing. First, telecoms used frequency translations and mixing to enhance signal quality and minimize interference. For instance, cell phone network convert high frequency antennas signal into lower frequency via frequency translations. This result is better signal quality and less interference from other devices. Radio astronomy utilizes frequency translations and mixing to gather data about the universe. The use of frequency mixture in radio telescope allows astronomers to create detailed image of faraway objects by combining signal from multiple antennas. Further, frequency translations can be employed to change the frequency of received signal for better analysis. Signal processing utilizes frequency translations and mix to manipulate signal and extract data. For instance, in our radar system, frequency translation is utilized to calculate the distance between the radar and a target by measuring the time delay between transmitted and received signal. Frequency mixing is also employed to obtain information from intricate signal such as those produced by medical image device. In my next slide, advantages of frequency translations and mixing. Frequency translations and mixing offer many benefits in fields like telecommunications, radio astronomy, and signal processing. Improved signal quality is a major advantage. By translating or mixing frequencies, unwanted noise and interference can be eliminated, making the signal clear and more reliable. This is especially important in telecommunications where clear communication is critical for successful operations. Frequency translations and mixing also has the benefit of signal information extractions. By changing the frequency of a signal, it becomes possible to extract various types of informations such as amplitude, phase, and frequency modulations. This characteristics is vital for signal processing application that depend on information extraction for interpreting and analyzing data. In my next and the last slides in these presentations is conclusions. To summarize, shifting frequency through frequency translations and mixing is the key in many fields, including telecom, radio astronomy, and signal processing. This method aids in improving signal quality and extracting information. These conversions has touched on different types of mixtures, applications of these techniques, frequency conversions, challenges, and the future outlook. The importance of frequency translations and mixing is obvious. These concepts are vital for progress in science and technology and for improving our daily lives. Understanding them will allow us to make incredible discoveries and push the limit of what we can achieve. So, thank you for listening these presentations.